Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I am learning quickly, I don't claim any real expertise. Today, we're looking at the 47th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Alright, problem 47 is distinct primes factors. The first two consecutive numbers to have two distinct prime factors are 14 and 15, 2 times 7 and 3 times 15. The first three consecutive numbers to have three distinct prime factors are those three, breaks them down. Find the first four consecutive integers to have four distinct prime factors each. What is the first of these numbers? Okay. So the biggest challenges here is some of these factors might be squared, I think. So at first, we might have to ignore that. We'll see. This is all we really need for the problem statement, I think. Okay. Copy our two lines we love. Okay. So. How do we want to approach this? First, let's try to solve the smaller version of the problem. Specifically, in this case, find these two distinct prime factors. So let's see. I'm going to call it target equal to. I'm setting this as a variable specifically so that I can change it very easily later. And then primes is an empty array. And then I'm going to have first, which is an integer. Or I'm just going to call it consecutives equals that. And then we're going to just print out consecutives later. That way we can see the whole list, and that'll give us a way to visually verify that they're, you know, at least actually consecutive. And then num consecutive equals 0. Okay, so now for... Actually, let's just do n equals 2. While num consecutive less than target I'm going to do n plus equal to 1. So n is kind of starting as 2 here, sort of. And then what do we want to do? We want to check we want to make an isPrime method. And in this case, if x equals 2, return true. If x less than 2, return false, just in case. And then for p in primes, I might have to move this declaration up. I'm going to go ahead and do that just in case. If p greater than the square root of x, break. Otherwise, if p, or if x mod p is equal to 0, return false. And then if we get out of this loop, I'm going to go ahead and throw 2 in here. We're going to say primes.append x return true. Okay, so maybe not the most efficient way to find a prime, but it'll work for this, I think. Okay. And what we're going to say is if not is prime n. Because if it is, or actually, if is prime n, then consecutives is an empty, and consecutive resets to 0. And then we're just going to make this an else. So we have, let's say, the number 4. We're going to say for p n primes, if, let's see, I don't think we want to reuse n. Checking equals n. Checking mod p equals 0. Checking equals checking divided by p. So we want to increase the number of factors and modify checking. And here's what we're going to say is if p greater than checking divided by 2, then we want to break. And I think that this probably will not work for 3, but let's see if we can get it to work for 2, the easier use case yet. First, or checking is 0. Okay, so we went through and we counted the number of prime factors we could find. Let's do it this way. If we use factors as a dictionary, then we can do that, and then we can have this be a while loop. And that should catch our other case. So if length of factors equals the target, then we break. Else length of factors equals target. Then we want to add this append here, and we want num consecutive plus equal to 1. Okay, so we found that. And we don't actually want to break here. What we want to do is we come down in here, and why am I holding the same information in 2 places effectively? If length of the consecutives oh, I guess that's handled here, but still, I can just say length of executives instead of that. Okay, so I think that this will work for the target 2 case. Let's find out how correct I am. Okay, we got 195 and 196. Going back, that is very clearly the incorrect answer. So, I'm going to go ahead and here I'm going to say if n equals 14 or n equals 15, print consecutives. Okay. I'm going to do go ahead and print out some information. Checking is now checking for n of n. Looking at prime of p. Actually, I'm gonna go ahead and move this. And let's see what we get. Okay. Checking is now 14 for n of 14, looking at prime of 2. Looking for prime of 5. This should probably be a 1. I'm gonna do another, and if it's 14 or 15, F factors found, factors. Let's find out. Ah. Okay, so this was meant to be n divided by 2, not. Okay. So now we're working. Let's go ahead and delete all of this noise. Okay, so just a couple of mistakes there where I did checking divided by 2 instead of n divided by 2. I could have said p greater than checking instead. And in fact, that's probably a much better strategy. Because obviously, if p is a larger number, then there's no point in checking whether it's a factor of the number it's bigger than. Okay, so run it again without the noise. We're getting out the 14, 15 that we expect. Change the target to 3. We're getting the 644, 645, 646. Just like we thought. Change the target, or just like we should. Change the target to 4. This is taking longer to run, of course, because there's just many, many more numbers involved. Unsure how many. But, I think it'll give us the correct answer. Okay, so that definitely, like, it took a lot longer. It took 12 seconds. But that definitely gave us 4 consecutive numbers. Let's find out if that is the correct answer. There we go. All right. Let's review our method here real quick. So, what we did is we created a target variable and a consecutives array. We started with n equal to 1 so that we could technically start with n equal to 2. So when we did is prime, 2 would be included. We have our isPrime function that's very, very similar to what we've done for isPrime in the past. And then for numbers that are not prime, or sorry, for numbers that are prime, it basically resets this array because obviously we're no longer dealing with a consecutive number. For numbers that are not prime, possible that those are the correct ones, so we say that we are checking starting with the number n. We create a factors dictionary so that we don't have the same key more than once. So that catches the part where this one is 2 squared. And like what we're setting it to doesn't actually matter. We're just throwing it in there. And let's see. So for each of our prime numbers that we have found so far, by definition, all of the prime numbers are going to be greater than n, but we're also checking to see if this prime is greater than the number we are checking. We're just going to break out of this loop because we know that we have found any and all prime factors of this number n. Because checking is either n or a factor of n. So then for every prime, we check whether checking mod p is equal to 0, and if it is, we note that p is a factor, and then we reset checking to checking divided by p. So we come in here with, let's look at 644. 644 is not a prime. We set checking to 644. We create this empty dictionary. We start with the number 2. 644 divided by p, or divided by 2, is, of course, an integer, so this will pass. We set 2. And then 644 divided by 2 will become 322. We'll be in this while loop again. Next time it'll come out as, what is it? 322 is like... 322 divided by 2 is going to be 161. So then we keep going through, we go back to the outer for loop there. And then we check whether the number of keys we have in our factors dictionary is equal to the target, because the number of distinct primes is equivalent to the number of consecutives in a row that we want. And if we fail this check, we have to set consecutives back to an empty array, because we know that we hit a number that is not meeting our criteria. So, yeah. And then we just printed out all of the consecutive numbers that we found. So I think that we're good to call it a day here, and I will catch you in the next one.